Today I start one important topics related to elementary matrix operation and elementary matrices. Okay, also known about this elementary matrix. Okay, plays an important role in linear algebra. Okay, that means if we handle elementary matrix, then obviously we further that means further going to another matrix or some that means connection between matrix and linear transformation and some topics related to that. So today we start from definition of this elementary matrices. Okay, so we're going to write this definition now. Yeah, let A be an M cross A matrix. Okay, and any one of the following, any one of the following. Okay, three operations on the rows of A, three operations on the rows, even in bracket columns. Okay, of A is called an elementary. Okay, is called an elementary row or in bracket column operation such that means A be an M-cross-N matrix and any one of the following three operations on the rows or columns of A is called an elementary row or column operation. First one, we write it here. Interchanging any two rows, columns. Interchanging any two rows in bracket columns of A. Okay. Second, multiplying any row of A by a non-zero scalar. Multiplying any row of A. Okay. Sorry, row in bracket obviously column. Write it better. Column of A by is non-zero scalar. By a non-zero scalar. Okay. Number 3, adding any scalar multiple of a row. Adding any scalar multiple of a row bracket column, okay, of A to another row and column, to another row or column. Okay, that means adding any scalar multiple of a row or column of A to another row or column. Okay, then this one are three operations. Okay, interchanging any two rows columns of A, multiplying any row of A by a non-zero scalar column by of A by a non-zero scalar, and adding any scalar multiple of row of A to another row. Okay, these three are three operations. To easily we handle these operations, and these three are three operations, and we call these operations are called elementary row operation or elementary column operation. Now we write it in this way. Any of these operations, any of these operations, okay, is called an elementary is called an elementary operation. Okay, which called an elementary operation. And elementary operations are of type 1, type 2, type 3, depending on whether they are obtained by 1, 2, or 3. That means this one are type 1, okay, elementary, and this one type 2, and this one type 3 elementary operations. Okay, so not a problem at all. We're going to discussion about some matrices, okay, and obviously we see these operations by an example. Okay, so we erase that portion and going to further discussion of that. Okay, so we know about elementary operation, okay, elementary row and column operation. Now we also going to elementary matrices. Okay, going to one example. Okay, so we write a equal to what? A equal to 1, 2, 3, 4. Here 2, 1, minus 1, 3. Here 4, 0, 1, 2. Okay, this that means this matrix A. Okay, now interchanging the second row of A with first row. Okay, then we get operation interchanging second row of A, second row of A with first row. Then what we obtain? We obtain this one, that means some another matrix B. First 2, 1, minus 1, 3, 1, 2, 3, 4, 4, 0, 1, 2. Okay, in this way we also write this one. Next we also going to multiply second column of A by 3. Okay, multiply multiply second column of A, second column of A by 3. Okay, we get what? We get this one, C equal to 1, 2, 3, 4. Sorry, second column. We write it 6, 2, 3, minus 1, 3, 4, 0, 1, 2. Understood? This one is one of the type 2 column operation, and this one is the type 1 row operation. Okay, so this one what? Type 1 row operation. Okay, this one is type 2 column operation. Okay, then what happened? Next we write it here in this way, that means adding. Okay, we write it in here, adding 4 times, adding 4 times the third row of A, adding 4 times the third row of A, okay, to the first row, to the first row, to the first row is an example of an elementary row operation of type 3. Then we get what? We get in this way, we write here m, okay, m equal to what? Adding 4 times third row of E to first row. That means here 4 times 4, 4, 16, 117, okay, and here 2, sorry, 17, 2, and here what? Here 4 plus 3, 7, here 8 plus 4, 12, and remaining as same 2, 1, minus 1, 3, 4, 0, 1, 2. Understood? Not a problem at all. Then what happened? This one is the type 3 row operation. Okay, type 3 row operation. Okay, understood? Not a problem at all. We easily handle and we easily understand row operation and column operation. That means, sorry, elementary row operation and elementary column operation we easily understood now. Now we erase that portion and going to further discussion of that. Okay, so we erase that portion now. So we write now one definition. Okay, one definition we write here, an n cross n, an n cross n elementary matrix is a matrix obtained by an n cross n elementary matrix, okay, is a matrix obtained by performing an elementary operation on Im. Is a matrix obtained by what? Performing an elementary operation on Im. Okay, elementary operation on Im. Okay, an n cross n elementary matrix is a matrix obtained by performing an elementary operation on In. Okay, and the elementary matrix is said to be the elementary matrix, okay, is said to be the elementary matrix is said to be of type 1, 2, or 3, okay, according to further the elementary operation, the elementary operation, okay, elementary operation performed on In, performed on In is a type 1, 2, or 3, Okay, operations respective, operations respective. Understood? So we also going to discussion of another way. That means we what an elementary matrix is, which matrix performing an elementary operation on IN. Okay, in IN that means some elementary operation is performed, then an elementary matrix obtained. Then the elementary matrix is said to be of type 1, 2, 3 according to whether the elementary operations performed on IN is a type 1, 2, 3 operations respectively. Okay. So now we're going to discussion of that interchanging of first two rows of I3. Okay. Interchanging of first two rows. First two rows of I3. Okay, produce the elementary matrices. Produce the elementary matrices. What produce the elementary matrix? Which type of matrix? This one E equal to 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay, this one be an elementary matrix. Okay, and obviously another one are obtained in this way. Now we write that means two theorem, okay, related to that and consequent examples to related to that theorem, okay, and some results also we write in that topic. So we erase that portion and going to further discussion of that. Okay. So that means what we then write here, we write one theorem related to this elementary matrices. Okay. Let A belongs to M n cross n A. Okay. And suppose that B is obtained from A, and suppose that suppose that B is obtained from A. Okay, B is obtained from A by performing an elementary row or column operations. By performing elementary elementary row or column operation. Okay, let A belongs to M n cross n if and suppose that B is obtained from A by performing an elementary row or column operations. Okay, then what happened? Then there exists then there exists then there exists an M cross n M cross n M cross M or N cross n. Okay, elementary elementary matrix E elementary matrix E such that what P equal to EA, okay, or B equal to A. Okay, the next then is in fact Yeah, full stop. Okay, in fact, P is obtained from IM. P is obtained from IM. Okay, here IN by performing by performing, okay, the same elementary row or column operations, by performing the same elementary row same elementary row operation or column operation, okay, same elementary row or column operations as that which was performed on A, as that which was performed on A to obtain B, okay. That means in fact E is obtained from IM by performing the same elementary row operation as that which was performed on A to obtain B. Okay, and conversely, okay, if E if E is if E is an elementary M cross A, an elementary M cross A or n cross n matrix, okay, then then ea here ae, okay, is the matrix obtained from is the matrix obtained from a obtained from a, okay, by performing the same by performing the same elementary row or column operations, same elementary row column operations, okay, operations as that which which produces e from im in bracket ia, okay. So that means E is obtained from IM by performing the same elementary row or column operations as that which was performed on E to obtain B. And conversely, if E is an elementary M cross N matrix, then EA is the matrix obtained from A by performing the same elementary row operation as that which produce E from IM. Okay. So we erase that portion and going to further discussion of that. Okay, that means this one is too easy. E is an elementary matrix, then EA is the matrix obtained from A. How that means EA is obtained? That means if E is produced from IM and this one multiplied by A, then obviously EA found. Okay, understood? That means we also in this way we obtain this one. So we erase that portion and going to further discussion of that. Okay, we give some example related to that theorem. Yeah. So we write some example here. Okay, that means E is obtained in this way: 0 1 0 1 0 0 0 0 1. Okay, then that means EA equal to B. We write here A equal to what? A equal to 1 2 3 2 1 4 5 1 6. Okay, then EA equal to what? EA equal to, we write it here in this way: just 2 1 4 1 2 3 5 1 6. Okay, in this way we write this one. Sorry, we first that means multiplied this one. Okay, in this way we also check this one: 1 2 3 2 1 4 5 1 6. Okay, then how, what we obtain? We also see that this one 2, this one 1, this one 4, next this one 1, this one 2, this one 3, then that 5 1 6. That means if we multiply then this one obtain, and obviously if we then just change this to row, then obviously this one obtain. Okay, so any one procedure you can apply. Okay, now same that means thing happen. Okay, if we done anything else then same thing happen. Okay, so we that means obviously discuss that portion. Now we erase that portion and going to further discussion of that. That means we construct A equal to that. Then what happened? That means if we write here E equal to 1 0 0 2 1 0 0 0 1, then this one how we obtain this one? That means just first, that means first row multiplied by 1 2 and added to second row. Okay, so here EA we obtain in this way. How? That means 1 2 3, first row multiplied by 2 2 2 4 and 2 2 4 1 5 3 2 6 4 10, and we have 5 1 6. Okay, in this way we are again we multiplied this two, then what happen? We also check it now. Okay, 1 2 3 2 1 4 5 1 6. Then here 1 0 0 1, again 2, again 3, and here 2 to 4 4 1 5 6 14 and 5 1 6. Understood? These two are same, so that means we quickly do it. Okay, that means by this theorem we just, that means just remind this theorem, then quickly we do it. That means this multiplication is not needed. So this one is an easy theorem. We also see it by so many examples. This one is right. And today we also known first elementary row and column operations, second elementary matrices, and obviously that means we see the examples of elementary operation and example of elementary matrices, and then we talk about one theorem and we also check it by some example. Okay, so if you get this type of videos, please subscribe my channel, and if you mm, gives like, please click on like options, and if you have some questions, comments, suggestions, please write it in comment box. So today I'll stop here.